So let's talk about queues, okay, for the data structure for this video. So queue, we already know queue. We did that all the time. First in, first out. Go to the bookstore, line up. First, have to go out first, right? FIFO. And operation, we have constructors NQ and DQ. Now the question that I have is, what the efficiency of the constructor NQ and DQ, and we use big O to measure. And you see that type of question on your test. We already know simple queue, right? NQ pretty much just put number into queue, right? NQ3. DQ just take the front out. Now how to implement it, right? It's going to be depending on the efficiencies here. And we said when we implement this, we have to make sure that we have to do exception to taking care. We don't want to DQ an empty queue, right? So it's going to be queue underflow exceptions, and we have to use isEmpty method to help. We don't want to NQ a queue that is full if we use an array to implement this. So we have queue overflow exception, and this array doesn't have enlarge method, right? We have is full to taking care. So queue interface pretty much just going to have DQ, which throw queue underflow exception, right? And we use isEmpty. And we have another type of interface for bounded queue interface, for in the case that we use array and array doesn't have enlarge, when you NQ, you have to throw queue is overflow and use is full. Okay, so unbounded queue interface pretty much just no boundary, so that could extend the queue interface which NQ, right? Then we have NQ, DQ, right, for this one. When you DQ, just take care of an empty queue. Don't have to worry about the full, right, and overflow queue. And that's the UML diagram. Now, we said when we implement a queue, we can use array to implement, right? And when you use array, the question is, how are we going to implement the queue with array? So this is a queue. We NQ A, B, C, D, right? And front is pretty much at index 0. When you do DQ, 0 is gone. But you have to move everything else, shifting the location B, C, D, right? So if you implement that way, we can see that we need a loop, right? So it's going to take efficiency about big O of n, one loop, to shift them, right? So if we do that way. So you have to make sure on the test, you have to know what type of implementation that is asking you, okay? Most likely, we assume that you look at the textbook and we're going to reference back to the code of the textbook. Okay. Like for example, if I use, let's say for example, here, if I'm talking about what's the efficiency of this NQ method, right? By using array. So if it's the floating front design, okay, floating front meaning this one is not floating front. This one, if you have fixed front, you have to shift this. It's going to take bigger of n. Floating front means you can actually keep tracking of your front. Now fronts move to index 1. So whenever you NQ, it's still put at the end, just shifting index, right? When you do DQ, it's not shifting the whole thing. So you just move the index to move your front index to 1. In this case, DQ take A out, front index becomes 1. And if we talk about floating front, meaning what should be the big O. So now, if we subtract the index of the front every time, it will cause about constant time, big O 1, right? But what happens when it reaches number 4? It's going to be index outbound if we keep subtracting like that, right? So we need to have the technique we call wraparound with the floating front design, right? Which, when it reaches at the end, like for example, there's no room at the end of the array. Front now is 3. When I do DQ, it's going to be, and when I do NQ, rear, we have no 5, right? And I want to NQL, then we have to look at moving your rear to 0. Right, when rear is at the end, then we have to wrap around back to the front. And no longer the front now, because wrap around, there's no such back and front as a linear, but it's layering, so we have the index to keep tracking on the front instead. And by implementing this, you may see that this is how we're implementing it, right? We declare it. So let's look at what is the big O of this constructor. You see down the test, right? So use array bounded Q. So if the test says what's the big O of array bounded Q, now you should know the constructor you're going to declare new and the size. So this is going to allocate the memory, so it's about n. So this is going to be big O of n. Okay, so this is a big O of n, even though you don't see loop, but this is actually doing that when you allocate the memories of an array. Okay? Same as this, right? Max size, depending on the max size. So now let's look at NQ. So what's the big O of this NQ? So how to implement NQ? We said if we take care first, if it's full, how you know it's full? So big O is depending on its full method, right? So depending on how we implement its full too. If its full takes only linear, only constant time big O of 1, then this part is big O of 1. And how will we get to big O of 1? Because we can just check the size. Whenever we do NQ, we do the num elements equals num elements plus 1. Then we just say if num elements equals to the array size, then it's full, right? Otherwise, it's not full. So it should be just big O of 1, correct? So this is big O of 1, then we're going to throw in errors if it's full, which should not take any more than big O of 1, right? So this algorithm is just changing the rear, right? By looking at my current rear plus 1. So if I'm at 4, that's the end of the size, plus 1 becomes to 5. Then I mark the length, right? So when I mark the length is index 4, that means length is 5, right? 0 to 4, right? Length is 5. 5 mod 5, I get the new index of rear to 0. Because we made it 0. So let's make it wrap around. And this only take big O of 1, right? So assignment the elements to that new location of Q and implement. So this NQ is a constant big O of 1. Make sense? So that's what you should answer, right? For efficiency here. DQ is similar, right? Just the logic that try to find a new front. Like, for example, it's empty. We'll talk about that. So we create a, so this one is going to return, right? So that's why we just say Q front, right? That's DQ, just return the front values back, whatever at the front, but we're going to move the front. But we're going to need to, this is an array, then we have to assign node to that location. And then change the front. Like for example, if front is 0, 0 plus 1 by increment 1, then we get to the next index. But make sure that front can be reaching at the end also. So that's why we have to mod q.length, because this is wrapping around, right? Like now, one mod q.length 5, then it's still 1. So it's just new front is 1, and increment the size. And what's the efficiency of this? Big O is big O of 1 again, right? Constant time. Like I said, we don't care about how many instructions 1, 2, 3, 4, 5. We're going to say constant time big O of 1, right? And this is empty and is full. We just talk about that. It's empty, pretty much just talk about if it's equal to 0, returns, right? True. Now, that is, the one that we just looked at is the bounded queue, right? Using array. How about if I use array and bounded queue? Same in the test, you guys have that type of question. I asked you, what should be a big O of array and bounded queue in queue? Then you have to think about how we implement that. So now when we're dealing with unbounded queue, we have to create a new larger array, okay, when it happens to reach the size, right, of the old array. And then we call the enlarge method, right? And this method pretty much is instantiate an array with a size equal to the current capacity plus the original capacity. This is the algorithm that they designed, like pretty much double the size, right? And we don't no longer need it full, right? Because it's unbounded. And it's empty, it's unchanged. So let's look at the constructor. Pretty much just do the big O of n, right? Big O of n the same, just create an array, right? And now we have enlarge. So what should be the efficiency of enlarge to? So we declare an array. And whenever you do this, you know that's going to be n, right? That's going to cost n. And this is an array that is double the size, right? And this is going to be loop, right? Copy the contents from pretty much just the original array, which is a smaller array, into the new array. You see larger array here, and copy all of them from the queue, right? And also, this is just keep tracking on the front, right? Where the front is, so use the same algorithm because it's wraparound, right? And after that, just assign the larger, which is new one, back to queue. So this costs n, this also costs n, right? This is going to be just 1, 1, 1, right? And make front to 0, and then num elements. This is rear, right? Which is num elements minus 1. So you see this is about 2n, right? Which the constant will drop, so this will be the big O of n, right? Well, enlarge. So now when we talk about NQ, what should be an NQ? For unbounded, it should be n instead now, right? Because it's depending on enlarge instead of a constant. So that means when the question asks you, you have to know, hey, we're dealing with unbounded. NQ is going to be big O of n. DQ is going to be the same, which is 1, right? Which is an array. This is just look at the application. Palindromes can use the Q to help.